Okay, hi everybody. In today's lesson, we're going to be estimating p in the binomial. So, as you know, the last two lessons, 8.1, 8.2, we were looking at estimating the mean for a large sample or estimating the mean for a small sample. Now we're talking about a binomial distribution, which we've done a lot with binomials in the past in prior chapters. We're looking at the same idea here, but in terms of a binomial. So let's get right into it. So just a couple of review vocabulary. R is the number of successes. N is the number of trials. All right, P is our population proportion. So think of it as your mean, but in terms of the binomial distribution. And P hat is the sample proportion of successes. I put a little review here about what is a binomial. Remember, it has a fixed number of trials. Let's see here. Fixed number of trials. All the trials are independent. Each trial has only two outcomes, either success or failure. For each trial, the probability of success is the same. If you recall, Q is 1 minus P. So if the probability of success was 30%, then Q would be 70%. The main goal is to find the probability of R successes in N trials. And we had talked about a point estimate for P and Q. All right, and in a binomial, when we say P, we're talking about the mean. So we're saying the mean in a binomial distribution, but in this case, in a binomial, we're going to call it P. We will need to check that the number of trials is sufficiently large. So in other words, n times p is greater than 5 and n times q is greater than 5. The binomial histogram is shaped approximately like the normal distribution curve. And it's been a while, but we did look at these formulas where the mean was n times p and the standard deviation was n times p times q. This means that once we standardize, we're going to be looking at z-scores. All right, so this page is really just all the directions. I snipped this box out of our textbook just to, give you that textbook definition of how to approach a confidence interval for a proportion. But then I just tried to put it in very nice, neat, organized steps for us, and that's what I'm going to focus on this page. So for all of these types of problems, we're going to be first checking to make sure that n times p and n times q is greater than 5, right? We're going to identify r and n. We're going to calculate our point estimate. We're going to calculate the point estimate for q, p hat and q hat. Determine the level of confidence, that'll be given. Determine the z-score. We're either going to use this table here or you could use the bottom row of table 6. We're going to find the maximal area of tolerance, just like we were doing for large and small samples. We're going to find the left-hand and right-hand boundaries, again, just like we were doing for large and small samples. And then we're going to write a probability statement. Okay, so here we are on practice problem number 1. A study of recent graduates from Studymore University indicated that out of 1,527 graduates, 1,038 had changed their major at least once. Form a 95% confidence interval for the proportion of students at Studymore who changed their major at least once. Very important word here, proportion. That's going to remind us that we're working with a binomial, all right? And whenever we talk about binomials, we really want to identify what success is. So in this case, a success is a student changes their major at least once. So let's write that down. Okay, R is the number of successes. So that's 1038. That's how many people actually change their major at least once. N is the number of trials. All right, right here. We're forming a 95% confidence interval, so C is 0.95. We're going to look at the z-score for 0.95 right here, right? So we're getting 1.96. And we're going to find the point estimate for P and the point estimate for Q. So that's going to be equal to P hat equals R over N. So P hat is equal to 1038 over 1527. When we do that in our calculator, we're going to get approximately 0.68. And the point estimate for Q is Q hat equals 1 minus P hat. Q hat is equal to 1 minus 0.68, which is equal to 0.32. Now at this point is where we would pause and check to see that, let's go back to this page here, right? We want to check to see that n times p is greater than 5 and n times q is greater than 5. So we would put it in our calculator just to make sure. And I have here p hat, p times n, and I'm getting 1038, definitely greater than 5, and 0.32 times n, which is 488, definitely far greater than 5. Now, as far as that step goes, I can pretty much guarantee you I'm not going to pick anywhere it's not going to be greater than 5, but I just wanted to show you that for this problem. Now, how do we find E? We're going to write the formula down here. And we've got all right, so we know that our z-score was 1.96. We're just going to fill everything in, make it nice and easy here. You of course, will have these formulas copied down onto your formula sheet. No memorizing here. I'm not a big fan of memorizing. It's kind of a waste of time if you can just look it up. And we get 0.02 when we do that in our calculator. Now, again, you want to be really careful when you put this in your calculator. All right, I would pause the video right now and practice that because that is the number one area where students tend to make mistakes. The left-hand boundary is p hat minus e. The right-hand boundary is p hat plus e. So, of course, p hat is 0.68. We found e to be 0.02. So we're getting 0.66 for our left-hand boundary. And for a right-hand boundary, we're getting 0.70. And lastly, the most important part here, we're going to write our probability statement. The confidence interval, of course, is just 0.66 to 0.70. And the probability statement would say that we are 95% sure that, now instead of mu, we're saying p because we're talking about a binomial, is between 0.66 and 0.70. All right, let's take a look at one more problem. Oh, attending sports events, very fun time for everyone, right? So attending sporting events is a popular source of entertainment. When 1,000 people were surveyed, 590 said that getting together with friends was an important reason for attending a sporting event. Let P be the proportion, right? Very important word. We know we're dealing with a binomial of all people attending a sporting event to be with friends. Find a 99% confidence interval for P. This is a binomial. It's always good to identify a success. In this case, a success is a person attends a sporting event to be with a friend. Okay, that was a mouthful. R in this case is the number of successes, so how many people actually said that was true, 590. N is the number of trials, so how many people were, asked this question. Confidence interval, Find a 99% confidence interval. We're looking for z sub 0.99, right? Right here, 2.58. The point estimate for p hat, is r over n. So we just look at our information we have all filled out above. 590 over 1,000. That gives us 0.59. And q hat is equal to 1 minus p hat. Okay, and we get 0.41. Now we have to calculate E. Always good to write the formula out first, just so you have a good reference as you're going to fill it all in next. Only takes about 10 seconds or less to write the formula, and it helps from making careless mistakes. So the z-score we got was 2.58. P hat is 0.59. Q hat is 0.41, all over 1,000. Pause the video, practice putting this in your calculator. When you do that, you should get 0.04. All right, left-hand boundary is p hat minus E. Right-hand boundary is p hat plus E. Right, p hat is 0.59 minus 0.04 and 0.59 plus 0.04. So here we get 0.55 and 0.63. So our confidence interval goes from 0.55 to 0.63. And if we write the probability statement, we are 99% sure that P, because we're in a binomial, we don't say mu, we say P, is between 0.55 and 0.63. All right, I hope you enjoyed today's lesson. That's it for today. Have a great day.